Welcome everyone to this webinar today, accessing nationally consistent groundwater information coming from ICEFORM and the Australian Groundwater School. So glad to see so many here today. This will be presented by John Sharples, Bureau of Meteorology. My name is Trevor Pillar, National Partnerships Manager here at ICEFORM, and we're so glad to see a large number of people joining us from across the globe. I see that America, South America, Africa, Australia, New Zealand. That's terrific. Thank you so much for joining us, and let's get right into this. All right then, let's get underway with the webinars coming up. You can see them there. I won't go through them individually, but there's a number of free webinars there coming up. And then the courses below that, I won't go into any detail right now, but you can see there's plenty happening here at ICEFORM and the Australian Groundwater School. Today, we're going to have 15 to 20 minutes by John, and then 20 minutes open slather for you to say what you like within reason, because we are going to record it, and we're going to email that link to you after the webinar for your colleagues, for yourself to view later. And finally, the feedback. We'd love to have your feedback. It takes about a minute to tick some boxes and helps us shape the future ICEFORM webinars. Right, that's enough of the introduction. Now for the main game. John Sharples from the Bureau of Meteorology is a senior hydrogeologist working with the Bureau's groundwater team and responsible for groundwater data management. He engages lead water agencies around the country and creates a groundwater database with 200,000 bores, water level for 200,000 bores, and salinity information. Fancy having a whole country of nationally consistent groundwater data. It's just like, it's almost miraculous, except probably cost hundreds of millions, and a lot of people's lives gone into it. And thanks so much for making the time today to do this. I'll give you a yell at the 15-minute mark, so a 5-minute call, so you know where you're up to. Yeah. Right over to you, John.
Great. Thanks very much, Trevor. Just while I'm getting my slides together here, I'd just like to say thanks to yourself, Trevor, and to ICEFORM for having me today. It really is a privilege and an honour to be here, and it was great to see that map just then with the dots of people all across Australia and around the world. So I thank you all for coming to listen to me speak today. So my name is John Sharples from the Bureau of Meteorology, and today I'll be speaking to you about how the Bureau has been doing a lot of work in groundwater, and particularly in data, to make nationally consistent groundwater information available for everyone online. So I thought I'd just start quickly by talking about this picture I've got here as my background. When you think about photos of groundwater, often you might think of a windmill or maybe a drilling rig or possibly an artesian bore. But here in Australia, we've got a lot of arid areas with low rainfall. And groundwater is particularly important in these areas because it provides base flow to the rivers and supports ecosystems, especially if there's a low water table. So this might not look like a groundwater photo, but it's actually showing you a nice groundwater-dependent ecosystem there, and that's the Finke Gorge in Northern Territory. But of course, it's not just the environment that uses groundwater in Australia. Between 1/5 to 1/3 of all water consumed comes from groundwater. And another way to look at those numbers is if we can look at the Bureau's National Water Account. So the Bureau publishes detailed water accounts for 10 regions across the country. And there they are on your screen, just showing you the coverage. And if you look at the amount of groundwater used in those areas, it's between sort of 10 and 20% depending on the year. So you can see that the groundwater is a very important resource for the country. And I'll just put a note there to say that these numbers you're looking at right now for the 2016-2017 National Water Account, that's not yet published, but it will be available on the 6th of June. But of course, the story is quite different in some of those locations. So if you look now at the Daly region, which is in the very north of Australia, if you look at that little map on the bottom right-hand side of the screen, we can see here that over 80% of the water used there comes from groundwater, and a large amount of that is used for mostly agriculture and some irrigation as well. Similarly now looking at Perth, which is in the southwest of Australia, 70% of their water source comes from groundwater, and a large amount of that goes to supporting their urban water needs, as well as some irrigation and agriculture there. So as you can see, groundwater is very important, and in some places it's a really vital resource in Australia. But you might be asking yourself, what's the Bureau of Meteorology doing getting involved in groundwater, and why do we have a groundwater program going on? Well, the story for that starts back in about 1997 when we entered the Millennium Drought, one of the worst, most protracted droughts that Australia's ever had, and especially in the southeast. We had over 10 years of almost continuous below average rainfall. And this put a huge amount of pressure onto the water resources and the water systems, particularly the Murray Basin, which was incredibly impacted by this drought. inflows for dams and urban water supply. Inflows were some of the lowest on record, and we were seriously worried about dams going dry. And the climate among farmers and water users across the country was very dire. And there was a perception there that more could have been done to manage the resource and also to make data available and more transparent so that people would understand the resource and understand what was happening with it. So in response to this, the Prime Minister at the time, John Howard, he announced the Water Act 2007. And this created new roles for the Commonwealth Government in water in Australia. So prior to this, the management and monitoring of water and groundwater was vested in each state and territory, and they were really the only people who were looking after the water resources. But the Water Act came along and created some new organisations. So it created the Murray-Darling Basin Authority, the National Water Commission, and the Commonwealth Environmental Water Holder, and gave new roles to the Bureau of Meteorology in water. So among other things, the Bureau's roles are to collect, hold, manage, interpret, and disseminate Australia's water information. That includes groundwater data. So in short, we don't own bores and we don't own gauges, but we collect data that's out there, collect of other people, and we standardise and publish it. And the legislative instrument we use to do that is the water regulations, which sort of sets out the what, how, when, and who of this water data collection. So in regards to groundwater, the water regulations state that the Bureau must collect data on bore and borehole information, groundwater levels, groundwater pressures, groundwater salinity, groundwater pH, as well as information on licence entitlements and groundwater extractions. Outside of the regulation, so in addition to that data we're required to collect, we also collect data on groundwater-dependent ecosystems, groundwater management areas, aquifer boundaries, both 2D and 3D, and some hydrogeochemistry data. And the reason we collect the extra data is I think that's very important and adds a lot of context and is very useful for interpreting that water regulations data that we do collect. Now, as I mentioned, the state and territory agencies are the main organisations who collect and hold that data, but we pride ourselves on working very closely with them and having a collaborative approach because they don't just provide the data to us, they also provide a lot of their expertise and their knowledge and their goodwill to make sure that we're all pushing in the right direction when we produce these data sets. One of the things we do to work with them is we operate a number of reference groups. So there's one for the general groundwater products and one specifically for groundwater-dependent ecosystems. And we have members from each state and territory, as well as other federal agencies such as Geoscience Australia, the Murray-Darling Basin Authority, and the Office of Water Science. I'd like to always thank them for their contribution to the good work that we do. So this sort of graph shows you the perception that prior to the Water Act, data was held by each state and territory, and it was a bit of a mishmash, and they're each doing something slightly different. So the Bureau's role was to bring all that data together and then to standardise it. And the result of all that good work, at 11 years now since the Water Act, and a lot of hard effort put in by a lot of people, is the Groundwater Information Suite. So this is the Bureau's offering for groundwater data. It's 4 products that are published online to make groundwater data freely available for Australia. I'll talk about each of these briefly. I'll spend a bit more time talking about the Australian Groundwater Insight because the Explorer and the GDE Atlas will have their own webinars from ISWARM coming up next month. So just quickly, I'll talk about the National Groundwater Information System and the Australian Groundwater Explorer. So the National Groundwater Information System, or NGIS, is really the backbone upon which everything else is built. The NGIS holds the bore and borehole information. I think we've got 870,000 bores in there at the last update from June last year. So the process by which we build the NGIS is to take the bore and borehole state data information. So that's information held by each state and territory. That is standardised by applying a consistent schema, terminology, making sure everything's got the same fields and that the same things are called the same thing across each state. We then apply the National Aquifer Framework to make sure that aquifers are called the same thing as well. And then we ingest that into our corporate geodatabase. And there it's combined with the time series information, water levels, salinity. And we also do some extra work in GIS, creating 2D bore lines and creating 2D and 3D aquifer surfaces and volumes. And all that data is then published online in our online data products, which I'll talk about, as well as it informs our periodic water resource assessments that the Bureau publishes. Now, the data inside the NGIS is exposed through the Australian Groundwater Explorer. So I'll just give you a brief look at the kind of information you can see here. So here we are just looking at some of the bores with water levels around Sydney. So I've just highlighted here bores that have groundwater level data. The darker dots are showing where there is more data available. The lighter dots, the light blue there, showing where there's less data. So this just gives you a flavour for some of the things you can access inside the Explorer. The maps are all in, you can interrogate all of the maps. So if you click on one of those bores, you can get a water level. So here's just showing you an example hydrograph from one of those bores. And we can see the blue line there showing the standing water level. And there's some extra information overlaid on that, just the percentiles for the water level. So showing is it above or below the average for that bore. And also overlaid there is a cumulative rainfall residual trend in grey to give you some idea as to whether this bore has any impact from rainfall. Where available, where there's log data available, we also provide some graphs of the bore log plots. And this log data and the water level data, that's all available in tabular form to download as well. Another thing we've been working on recently is 3D PDFs. So this is embedding 3D information into a PDF document. And we think this is a really useful and interesting thing to do because it makes what's quite complex GIS data that you usually need special software to look at and interrogate. It makes it really available for anyone on a standard desktop PC. So you don't need ARC or QGIS or anything to look at 3D aquifer data. You can do it through one of these PDFs. And I'll just explain what you're looking at here. So here's in the middle is the main map part of the PDF. On the right-hand side, you've got the contextual layers and the hydrostratigraphy layers. You can switch on and off there. And you can actually grab and pan these maps and zoom and turn them around and turn layers on and off. So there you can see I've turned a few of the layers off. You can see the bore lines there, the rivers overlaid. And it's just a really good, easy way to get people to, have access and to view this data. There's also some functionality there for doing cross sections. So you can, within the PDF, actually slice through back and forward to get some idea of the cross sections of this data. So this new functionality we're adding will be available from June this year. And it's updating the existing 3D PDFs, which are also available through the Australian Groundwater Explorer. This particular one we're looking at here is for St Vincent Basin in South Australia. And I have to thank the South Australian Government Department of Environment, Water and Natural Resources for collaborating with us on this project. But if you'd like to see more about the Explorer, ICE1 will be hosting another Bureau webinar on Thursday the 6th of September, and my colleague Eloise Nation will be speaking then. So if you want to know more about that, I highly recommend that you tune in and listen to her talk. Next, I'll talk about the Australian Groundwater Insight. So the Insight is a high-level interpreter product. It's aimed at people who are non-groundwater experts. So there might be, say, a policymaker or possibly a farmer who doesn't want to drill down and look at a hydrograph and a bore log, but they want to get some information about groundwater in their area. So it's designed to answer sort of a range of basic questions like what aquifers are in my area. So here's just a screenshot of the Insight, and this is a map we've got for aquifer extents across the country. And they are grouped basically into upper, middle and lower to help people have some understanding of the 3D layered nature of groundwater. It's also got information to answer things like where is groundwater licensed for use across the country. So here is a map just showing the location and relative size of groundwater entitlements, so where people hold a license to extract groundwater, and giving you some indication of where they are across the country. So you notice that in some areas there's a lot of licenses, in some areas there's not much licenses. And it's a pretty good indication of where there is groundwater, a good groundwater resource and also groundwater use across the country. We also got information to answer questions like what management areas might cover my property. And here we're just having a look at the management areas for the country, those darker ones, those darker polygons you can see on the map, where you've got multiple management areas overlaying each other. Once again, all of these maps are interactive. So if you click on the map somewhere, so for example, I'm just clicking here a bit north of Perth, you'll get some information about the name of the planning area there. Is there an entitlement limit? So is there a cap placed there and what is it? And then some information about the current levels of entitlement and recent use. But the Insight is not just for national maps. We can also zoom down. So if we propose that you're a researcher or you're a policymaker and you're interested in the Limestone Coast and Otway Basin, which is this area here in the southwest of Australia, it spans the South Australian and Victorian borders, those states down in the south there. We can zoom in and start looking at this area in a bit more detail. So the first thing you might ask is, where are bores in the area? And there's a lot of them. So we present this as just a density grid, showing you all the bores from the NGIS. The darker cells there showing you there's a lot of bores, lighter cells showing you where there are less bores. And this straight away sort of gives you an indication of not just where there are bores, but where there's a decent resource. We can look also and say which of those bores have data. And once again, the darker dots there showing you where there's more data for those bores, and the lighter dots showing there's less. Similarly for salinity, and once again, these maps are interactive. So if you click on one of those locations, it'll give you some information about the bores there and show you which nearby bores have water level and salinity data. And if you go and click on those bore IDs, you can see that pop up. That will take you straight to the Explorer with that site open, so you can look at the data in detail if you want. Now we can go back to that aquifer boundary data set that I showed you before. Click on that and say what aquifers exist in my area. So just clicking here, it's telling me that the upper aquifer, or the shallowest aquifer, is the Hanson Plain Sand. Underneath that, we've got a marl, and then the Port Campbell limestone, and then the lower aquifer there is the Dilwyn. Now in this particular area, I happen to know that limestone is a very important aquifer. So if I wanted to focus on that, I could turn the other aquifers off, just bring out that middle layer there, looking at that limestone aquifer, and find out a bit more information about what's happening in that particular aquifer. So the first thing I might say is, what's the groundwater quality like? And one of the data sets we produce there is just long-term average salinity for bores in the area. And straight away you can see that in the south, data is rated fresh to marginal, and that's on this map between 0 and 1,000 milligrams per litre, TDS. So that's in the south, moving across into Victoria. In the north, we've got those yellow dots, which is brackish, which is about 1,000 to 3,000 milligrams per litre. So straight away, you can start getting an idea of where the resource is of good quality. You might also want to know how groundwater levels are changing in this aquifer in this region. And here we have a trend assessment for bores. So this is a 5-year trend from 2012 to 2017, just telling you what's happening with trends in the aquifer across that time period. And you can see for the most part, bores here are either stable, which is those yellow dots, or declining, which is the downward brown arrows, with a smattering of a couple of them that are heading upwards. So we produce this information just to give you a quick snapshot of if there's any sort of regional trends and what's happening with the groundwater there. But you might say, well, is that a good or is it a bad thing? How do we know? And to give you a bit of context to answer those kinds of questions, we also present what we're calling groundwater level status. So this is an assessment of whether recent levels are above or below the long-term average. So here we can see that the blue arrows are indicating that recent levels in 2017 were above the long-term average for this bore, whereas for the red downward arrows, that recent levels in 2017 were actually below the long-term average for this bore. So I'll just flick back to the trends there. You can see that there's a lot of those bores that are heading down in the south are actually still quite a lot above average for their long-term levels there. So even though the level is declining, in terms of how that compares to the long term in the bore, the actual absolute level is still above average. Whereas in the north, the levels are below sort of the long-term average for that bore. And if I click back again, and you can see also that there's a number of them that are also declining there. So the reason for presenting this kind of data is to say that if you are unfamiliar with the region, or you want to just get a snapshot of information of what's happening in this aquifer in this region, you can come here and that can start framing the kinds of questions that you should be asking about resources in this area and their status. And of course, you can go back to that map I showed you before for licensed entitlements to get a feeling for where groundwater is being used in the area. And that can give you a hint as to what's happening. So you notice in the north there, there's quite a lot of licenses, but noting also that those larger dots are indicating larger entitlements. So potentially people extracting a lot more data, whereas in the south, there are still a lot of licenses, but typically smaller in volume. Lastly, I'll talk quickly about the Groundwater Dependent Ecosystem Atlas. So the GDE Atlas is a very important product for the Bureau. It's the national repository for the locations and attributes of groundwater dependent ecosystems in Australia. It provides information on 3 types of GDE. So there's aquatic, which is rivers, wetland, springs. There's terrestrial, which is all types of vegetation that access groundwater. And then there's subterranean caves. So I'll just point out this picture on the right-hand side is in the Wilson Nature Reserve in Western Australia. And that's a lovely river red gum with a bird nest in the top of it. So that's an example of what might be a terrestrial GDE. The Groundwater Dependent Ecosystem Atlas was first published in 2012. And in 2017, it received its first update. And that included new updated data from regional studies, which provided more detailed, more up-to-date information on GDEs in those regions. And there was also some tweaks to make the application a bit more usable. So here's what the GDE Atlas looks like. So this is showing you a map of the aquatic GDEs across the country. The blue information there shows you data from the national assessment that was first produced in 2012. And the purple there showing you where we've updated it with data more recently. And as new data sets come available, we intend to update this product going forward. The darker colours there indicating more high potential GDEs or more likelihood that that is a GDE, whereas the lighter colours are lower potential. As well as other apps, these things are interactive. So if you click on that GDE button on the top of the screen, which I've highlighted with the red square, and then select one of these polygons here, it will tell you a little bit about the GDE. So this is just east of Darwin in the north of Australia. And this is the Black Jungle Swamp, and that's a known GDE. So someone's done a study and determined that is most definitely a GDE there. We can look at a similar thing for the terrestrial GDEs. So once again, the green is from the national assessment, and the khaki colour is where we've added new data. And unfortunately, we don't have national coverage for this map, so there are some areas missing, particularly in Northern Territory. But we hope that as further studies are done, we can fill out those areas. And if I click on the Wilson Nature Reserve in Western Australia, where we just saw the picture of that magnificent river red gum, it tells me that's very high potential for GDE, so very likely that was a groundwater dependent ecosystem. And if you'd like to know more about the GDE Atlas, my colleague Ben Di Gregorio will be talking about it on Thursday the 2nd of August. That's another IceWorm webinar, and I hope that you can join him to find out more about the GDE Atlas then. So that's all from me. I hope that I've given you some insight into some of the work that the Bureau has been doing in groundwater, and particularly groundwater data, and making that available. If you'd like to look at any of what I've talked about today, I would like to invite you to come and visit our website. So that's bom.gov.au/water/groundwater. Or if you've got any questions that aren't answered today, or you'd like to get in contact down the track, do send us an email at groundwater@bom.gov.au. Back to you, Trevor.
Fantastic, John. That's an absolute feast. There's no two ways about it. And everybody stayed on board, so you definitely weren't boring. If I can go back to that horrible joke again. No, it's fantastic to see so many stay with us for the entire time, and such a huge amount of work in that 11 years. All right, let's just kick off with Simon Cruikshank in Northern Territory. Great to have you with us, Simon. Thanks for joining us. As a water manager, one of the greatest challenges, I'm going to bring it over here so I can read it. One of the greatest challenges when communicating water availability with landowners is informing the resource that they extract from. This is particularly important where geology is complex. As a comment, it's very important that we use common terms when discussing resources. To that end, I encourage the legend within BOM's information product to be developed.
Yeah, absolutely. And we, having a national focus, we are caught in this sort of in-between area of saying we want things to be standard across the country, but sometimes that conflicts with the local terminology there. And one thing we have done in the Groundwater Insight is we've tried as best we can to keep the local names for aquifers, so that for less informed users or people that aren't familiar with the different names of things, they can go there and, for example, they'll click and it'll say this is the Ulu or this is the Tyndall, rather than some kind of other geological name for them. So we are trying to make sure that people can find the thing they're after.
Wow, this is huge. Okay, we'll keep going, John. Thanks a lot for that. Great work, John. This is Basant Maheshwari, Professor Basant in University of Western Sydney. Great work, John. In what ways do the users of groundwater, say a farmer, can use the information you are collecting? Also, is there a scope for crowdsourcing groundwater data? This second question is coming up a little bit in these group of questions here. So how can farmers use it, and how can we crowdsource it?
Look, I'll address the first one, because that's a lot easier. Certainly, in terms of, say, a farmer's main interest usually in groundwater is to say, can I drill a bore, and can I extract water from it? So those are the two things they want to know. We're not involved in the management or the regulation of that. So there are certain licenses and things they'll have to attain to do that. But the information they can get from us is to say, what aquifers are in my area. So you can get a very quick look at, okay, here I'm over this, I'm over that, or I'm not over a major aquifer. And also to get some indication of things like groundwater level. So they can look at bores nearby and say, oh, well, depth of water table here is only 2 meters. So I probably won't have to drill forever. Or it might be 50 meters, and say, okay, that's going to cost me a lot more. And also, most importantly for extraction, probably is indication of the quality of the groundwater as well. So if they go and they click there and they say, all these bores are saltier than seawater, that gives them some indication about whether a resource is going to be suitable for them. In terms of that next question about crowdsourcing the data,
it'll come up again.
we have no specific plans to do that at the moment. I mean, one of our biggest concerns typically is just data quality. So even dealing with lead water agencies and water corporations, water utilities, we still are constantly talking to them about how to interpret the data, what the data means, how accurate it is. A classic example is someone's got a land surface elevation for a bore. So is that surveyed? Is it from a GPS?
Right.
Is it estimated from a DEM? If so, what DEM? So there's a huge amount of work just sorting out those issues. So if we were to open it up to crowdsourced data, there would be some very large caveats about how trustworthy that data was.
Yeah, this comment from Professor Andrew Ross in Canberra speaks to that very question. Andrew says, "Congratulations to Bureau of Meteorology on these very impressive products. How do you check and ensure quality and reliability of data you're getting near?"
Yeah, that's a big problem for us. We do spend a lot of time on it. The short answer is through our reference groups and that collaborative approach we do go back to the state agencies, so they're the owners of the data. And our first stop is if we notice something that's odd, we say, "Hey guys, we've noticed this. Can we try and see if that's is it a transcription error, or is it different? Have you sent us the wrong thing, or is there some way to explain it?" We also, with all the data, publish any kind of quality flags with it. So sometimes the data will come through and it'll have a flag on it that says this is quality F, not to be trusted. Or this is quality A, so we're quite happy with it. So it is something that we're constantly working on. While we're just on the topic, we have a current project working with Melbourne University to apply some automated QA checks to the water level data. That's currently being tested. So that would be, essentially it's a complicated outlier detection method. But that is one way of sort of sifting through all the data. So we're talking millions and millions and millions of data points that we've got to say, does this look like it's a bit of a spike in an outlier, or does it look like it's a real water level?
Yep. Michelle Clark asks, Michelle's from Toowoomba, Department of Natural Resources, how often is the data updated?
So currently, it's a bit of the water levels and salinity and the time series data is only 6 monthly at the moment. Once again, we're looking at moving to monthly updates for that quite soon, but that is a work in progress. And regards to the aquifer bore data, that's annual, and the GDE stuff currently is ad hoc. So it's a bit of a mix, depending on which particular data set you're talking about.
Sandra McPhee asks, Sandra is a wastewater project officer in Victoria, asks what parameters are we looking at for groundwater quality in relation to GDEs? What sort of parameters are we
So what data are we looking at for the actual quality?
Yeah, as a wastewater project officer in Victoria, what parameters are we looking for?
Yeah, we don't publish a lot of contaminant information. We don't really have any contaminant information, or the quality stuff that we've got specifically relates to sort of salinity mostly. So we're talking about quality for use. We don't have anything specifically about contaminants or what I imagine a wastewater person would think of when they're talking about quality.
Yeah, sure. Simon Cruikshank just backed up on the comment here. I think it's a worthwhile comment. National groundwater data collection and management standards are critical, and work has commenced in this space you probably know this, by the Australian Hydrographers Association, which is I'll do the same thing. That's great. That's great that they're getting into that. It's excellent. Alex Suckall from CSIRO in Adelaide has said, great talk, great tools. Two questions are most pressing for the environmental tracer research we're doing at CSIRO. How well established are relationships between a certain well and the aquifer this is pumping from?
So just quickly on that, how well are those established relationships? Once again, most of that data is supplied to us by the state agencies. It's hard to tell you exactly, I couldn't put my hand on my heart and say every single one of those aquifers that there has been checked, and someone looked at the log and said, yes, most definitely that bore is assigned to that aquifer. So it is something that's supplied to us. We have done quite a bit of work since then to extend that. So I showed those upper, middle, lower aquifer groups. They're kind of a coarse aggregation, and we have been assigning pretty much all of our water level bores to one of those aggregations. But once again, it's primarily an automated process. So How long is a piece of string, I guess, is the answer to that. It's some of them are very well established, some of them are not so well.
Second question, is there a way to find the owner of a well? It's important for us designing environmental tracer studies, groundwater dating, where getting in contact with the owner is one of the challenges.
So we provide information about who owns the data for that well. So that'll typically be the lead water agency. Right. We don't provide information about private individuals anywhere.
Matt McIntyre from Caloundra, Planning for Sustainable Development, has asked a couple of questions. The planning areas, are these based on national NRM boundaries?
No, the groundwater planning areas are specifically where management rules exist for groundwater. So they are specifically groundwater management areas. They are called, that might be, they're called WSPAs or GMUs in Victoria. They're called prescribed well areas in South Australia. They're just called planning boundaries in Western Australia. So these are the areas that have been declared specifically for the management of groundwater. I was just going to say that through the Insight, if you click on that, if you go to the Insight and click on one of those boundaries, there's a link in there which will take you directly to the legislation that's based on that polygon.
Matt's going on to say that regarding the 3D PDFs and aquatic GDE maps, are there abilities to download GIS layers to enable use for regional and sub-regional land use assessments?
So all the data in the 3D PDFs is, you could get it probably by contacting us. So if you're interested, groundwater@bom.gov.au. Regarding the GDE stuff, I believe you can download that directly through the GDE Atlas. So there's a download option there, and you can get that as GIS layers directly from the Atlas.
Jeremy Gleeson in Parkside, South Australia, Gleeson Water Brokers. With the 3D mapping tools, will this data be available for other states, or is this a pilot just using SA?
No, we are planning on having, in the first instance, one in every state. So the pilot in the St Vincent Basin will be the first one. The next one coming out will be for the GAB, so for the Great Artesian Basin. And then I'm not sure off the top of my head what the schedule is, but we're certainly going to have the Daly Basin in the Northern Territory, the Perth Basin, the Murray Basin. Forget what the other ones are, but we will certainly be rolling them out for each state and territory.
There's a question from New Delhi, Subhash Chand. Hi, Subhash, thanks for joining. That's great from so far away. Is this groundwater model freely available for use by researchers? Yes,
so everything I've shown you today is available through the websites, but certainly if it's in the GDE Atlas or the Explorer, you can download that through the web portal as well.
Matt McIntyre asks another question. System collects data on levels and salinity, right? Are there any plans to include in the future records of pollutants?
Currently, in the Explorer, we do have a little bit of information about hydrogeochemistry, and I believe that has some pollutants in there. That is being done in collaboration with Geoscience Australia. So that's the one data set that we don't actually own, or we don't hold that data. That's maintained and published by Geoscience Australia. We expose it through the Explorer. So if you go there and you select, it's on the left-hand side, it'll be hydrogeochemistry. You can have a look at the data set that's there.
Yep.
But it's certainly something we'd like to expand on in the future.
Yeah, for sure. Yep. Teo, I'm just seeing where Teo's from. I'll see research scientists here up in Brisbane, CSIRO. For most bores in the database, there is no aquifer boundary information. Does Bureau of Meteorology have a plan on it? Will it be a good idea to allow for end users to submit data? There we go.
Yeah, that's it. So I touched on that a little bit to say we are doing a little bit of work to assign those bores to aquifers by those upper, middle, lower groups. That's still a coarse aggregation. In terms of letting users assign those things, as I said before, we don't have any plans to do that, and there would certainly be a lot of issues around reliability there. For the one area where it might be possible is in aquifer assignment and bore log interpretation. So currently in the NGIS, we have multiple interpretations there. So if there are multiple logs, we can include them for each bore, and that might be somewhere where we could ingest data from, say, a research organisation.
In Bangkok now, Karthi is a researcher, and he said, do you foresee the increased use of web-based groundwater models running in the cloud using this kind of data set?
Quite possibly. The one thing that we get asked for routinely is some kind of API, so some kind of automated access to the data set, which is another project we have in the works. And the main use for that seems to be people that have a groundwater model and want to just have our data automatically feeding into that. It's certainly something that could happen in the future.
Yep, that sounds good. Milit Shah said, I noticed some of your regional study updates stopped at state boundaries rather than covering the aquifer or planning management units. Why is that?
Yeah, you're absolutely right. A few things sort of stop at state boundaries. While we've done quite a lot of work to try and smooth those data sets over, there are still a few that exist, and you might have seen one in the Victorian South Australian border we were just looking at. I mean, the reason for that basically is we're not, as I said at the top, we're not creating new data here. We're taking data that exists across the country and collating it into nationally consistent data sets. So, for example, that aquifer boundary data set we showed you came from, I couldn't say how many, base data sets. There's one from Victoria, South Australia, 2 from Queensland, the GAB, a separate one from the Murray Basin, and they've all been combined into a single data set. So there are still a few sort of artifacts at the boundaries, but we are trying to smooth those over as we get better and better.
Sam McGrath, he's a hydrogeologist in Melbourne. Hey, John, great presentation. Does the NGIS store telemetered water level data? There's increasing numbers of bores with hourly data recorded, and that's a lot of data.
It is, and we collect that data. I think some bores as frequently as 15-minute water levels get sent to us. In terms of what we publish there, we publish it on. In short, yes, we do have telemetered data. We only publish daily values to the external web. If you really want more than daily, you can email us and we can dig around and see what's available.
I think there's one there by Matt McIntyre about crowdsourcing of bore info, water resource quality and salinity, including outputs of significant EIS for large extraction users. Over time, this will produce a very useful MRV system. I'm actually not up with these acronyms, John. Are you on top of this to gauge the veracity of the EIA work and eventual outcomes, the success of remediation protection measures? I don't get the gist of the question, Matt.
So, asking about environmental impact assessments and coal seam gas is the CSG, I believe.
I see. Monitoring, reporting, verification, MRV. Monitoring, reporting.
So the Bureau, outside of the work I've been talking about today, the Bureau has done a lot of work on the bioregional assessment program, which was doing baseline assessments for all CSG basins across the country. And that was to basically provide the baseline data set on which future assessments can be based. Our role was really just as a data supplier to that. So we do supply groundwater data for that kind of work. Really, we see our role here as being, data transparency to make sure that the best quality data is available for environmental impact assessments, and that everyone, is using the same data and they're not getting a bit from here and a bit from there, but it's all in the one place and it's all standard. I don't know if that exactly answers your question, but hopefully that gives you some indication.
Alec Deslands, who is Alec, you're a colleague of my son back in uni days. Thanks for joining us, and you're from CSIR in Adelaide. Thanks, John, for the great presentation. With reference to the Otway Basin slide, what is the term of the average against which the current levels are referenced? Is there a tool for users to control this time frame?
The average there, off the top of my head, is back to 1995. And the reason we do that is because some bores have longer records and some bores have less records, and often it's linked to the climate. So we make sure that everything's more or less comparing to the same period of time. So you're looking at the values in 2017 compared to the average values back to 1995. And there's quite a lot of sort of complex logic there about choosing bores that are going to be representative of that period. So it's not just any bore with a water level. It has to meet quite a lot of criteria about saying it's got the right spread over the right period of time, and we're not just comparing one value here to one value back there. If you want to know more about that particular methodology, on the Insight in the top right-hand corner, there's an About page, and that has FAQ, metadata, and in there the method's explained in some detail. If you're still stuck, send us an email, groundwater@bond.gov.au.
John Sharples, thank you so much. It's been absolutely brilliant. Thank you, everybody, for your extensive and really insightful questions. It's been so much appreciated. But we've got to draw this to a close. Thanks for participating. The feedback form will come up as soon as you close this window, and there'll be a recording emailed to you. The link will be emailed to you. Notice the free webinars coming up there the next few weeks, and especially notice the HECRAS water modelling in Sydney coming up on the 4th of June. That course is filling, and we'd love to see you there. Keep in touch with us via Twitter. Everybody, thank you for joining us today. We're so pleased you could do it, and there was a lot. And particularly thank you to John Sharples from Bureau of Meteorology. This is the first of 3 in a series from the Bureau of Meteorology about their nationally consistent groundwater information. Thanks once again for everybody for joining us. We'll see you next time. Bye for now.